Okay, so far in this chapter, we've looked at determining angles and sides using the sine law, and we've looked at finding a side using the cosine law. Well, now we're going to look at determining an angle using the cosine law. In every situation we've looked at, the type of triangle that we have, the type of information we have from our triangle to start is different. So this is no exception to that. We're going to have different information to start our triangle at the beginning. What we're going to focus on is applying the cosine law again, explaining how to use the cosine law, and describing how the cosine law is used in problem situations. So the outcomes we're going to cover are solving a problem using the cosine law when a diagram is given. Here's a situation that we can use the cosine law to find a missing angle. If we know the three sides in a triangle, then we can use another version of the cosine law, different from what we looked at before, to find the missing angle. The reason it's different is, like when we looked at the sine law, we used a different version to find a side than we did to find an angle. Well, we can rearrange the cosine law to find a missing angle differently than when we looked at finding a missing side. So for triangle ABC, with sides little a, little b, and little c, it's expected that we know little a, little b, and little c in this example. The cosine of angle A is equal to b squared plus c squared minus a squared all divided by 2bc. What you might notice is that the angle A is what we're looking for, and our side A we subtract from the sum of the other two sides squared. So it's really important that you notice that when we're looking for angle A, we subtract the square of side A from the square of the other two sides. And these two sides show up again in our denominator. Okay, so I got cos A is equal to b squared plus c squared minus a squared, all divided by 2bc. Cos of angle B is equal to a squared plus c squared, the other two sides, minus b squared, which is the opposite to angle B, all over 2ac. And cos of angle C, if we're looking for angle C, is equal to a squared plus b squared minus c squared, all divided by 2ab. Here is an example of a side-side-side triangle. I have a little bit written on it because the way the triangle was initially drawn, it was an impossible triangle. So we have a side-side-side triangle. We know all three sides in this triangle. So in a situation like this, where I have a side-side-side triangle, I'm going to find an angle. And in this case, I'm going to look to find angle A. So to find angle A, I'm going to have to write the cosine law in a form where I can find angle A. So that means I'm going to write cos of A is equal to b squared plus c squared minus a squared, all divided by 2bc. So I know what A is, little a, I know what little b is, and I know what little c is. So I'm going to fill those information into my equation. So cos A is equal to 9 squared plus 8 squared minus 15 squared, all divided by 2 times 9 times 8. And now I'm going to go once again to my calculator. So I have my computer's calculator here. I'm going to type in on it 9 squared plus 8 squared minus 15 squared. When I do that, it gives me a value of negative 80. So I'm going to quickly go back to my equation here, my page. So that means that cos of A is equal to 80 divided by, go back to my calculator, 2 times 9 times 8 equals 144. So cos A is equal to 80 divided by 144. So what I'm going to do now on my computer calculator, I'm going to go back to it real quick. Cos A is equal to, actually let's simplify this. I have cos A equals 80 divided by 144. So if I want to find angle A, like I did with my sine law, I've got to get rid of that cosine ratio. So what I'm going to do is I'm going to find the inverse cos. So cosine to the power of -1, well, that's, apologies, this should be -80 up here as well, of -80 divided by 144. So now I'm going to go into my calculator. And on my calculator, I'm going to clear that out. I'm going to type in -80. Oops. Sorry, wrong button. Go back. Start over again. -80. The plus minus button is the negative button on this calculator. So -80 divided by 144 gives me this ratio here. Now what I'm going to do is I'm going to hit the INV button on this calculator. If you're using your own, it is probably the second or shift key. So click that, and you'll see if you do that on this, that my cosine now becomes cos to the power of -1, which is what I'm looking for. So I click cos to the power of -1, and it gives me a value of 123.7 degrees, or 124 degrees. So that means that A is equal to 124 degrees. That makes sense because the side opposite angle A is the longest side in my triangle. So 124 degrees, being an obtuse angle, is definitely going to be the longest side, or the biggest angle, apologies, in this triangle. The other two angles of any triangle, two angles will always be acute. If this one's obtuse, it has to be the longest or the biggest angle in this triangle. So we're going to look at this example here. The Niagara Falls Suspension Bridge was the world's first working railway suspension bridge. It was shut down over a century ago. Bridges like this are strengthened by triangular braces. Suppose a triangular brace has side lengths of 11 meters, 16 meters, and 9.2 meters. Use the cosine law to determine the angle opposite to the 11-meter side to the nearest degree. So this is a picture of the Great Western Railway's Niagara Falls Suspension Bridge. So first let's label our triangle. Here we have the triangle. We're going to call it triangle ABC. And we're looking for the measure of the angle opposite the 11-meter side. Well, that one in this case would be angle C, right? Because side C is the 11-meter side. So we're going to use the version of the cosine law that helps us find angle C. That, of course, is this version. Cos of C is equal to A squared plus B squared minus C squared, all divided by 2AB. So here's my triangle. I know that A is equal to 16, B is equal to 9.2, C is equal to 11. I'm going to plug that information into the cosine law. So cos C again is a squared plus b squared minus c squared all over 2ab when I'm looking for angle C. Put in my known information. So A is 16, B is 9.2, and C is 11. What I'm going to do next is put all that information into my calculator. You can do it all in a single step if you like. And here's how. Make sure your calculator is cleared out first. Then we put start a bracket, find 16 squared, add to it 9.2 squared, subtract from that 11 squared, and then I close my bracket. Then I click the divide button, open a new bracket, multiply 2 times 16 times 9.2, close my bracket, and that gives me a value of 0.7460 and a bunch of other numbers. So cos of C is equal to 0.746 and a bunch of other numbers. So once again, to find C on its own, I'm going to have to get the inverse cos of 0.746 something something something. On my calculator, I'm going to hit the second or shift key and then the cos key. And that'll give me a value of 41.749 something something something. In other words, C is equal to 42 degrees. So to summarize the cosine law, we've done a couple of examples. The cosine law can be used when we don't have a right triangle. So they're again called oblique triangles. We can find a missing angle in a triangle if we know all three sides. And if we know all three sides, we call it an SSS triangle, side, side, side triangle. And we can use our cosine. Oh, and I forgot to try in cosine here. The cosine law for triangle ABC as it's written would be cos A is equal to b squared plus c squared minus a squared all over 2bc. Cos of B is equal to a squared plus c squared minus b squared all over 2ac. And cos of C is equal to a squared plus b squared minus c squared all divided by 2ab.